To begin the alignment process, the IRs must be switched on to the nav position. The procedure is to turn on the number 1 aileroo first, then number 2, then number 3. When the switch is turned on, the on bat light illuminates, indicating that the emergency battery relay is operating correctly. The off light in the ADR extinguishes. When the battery relay test is complete, a line illuminates on the IR indicating light. When number 1 has stabilized, number 2 aileroo is switched on, and then number 3. All IRSs are now in the alignment process. Almost immediately, air data information is shown on both PFDs. On the ECAM memo, the message IRS in a line greater than 7 minutes appears. This message tells you that the alignment process has begun. It takes approximately 10 minutes for a full alignment, but the ECAM will only count down from 7 minutes. After approximately 30 seconds, attitude information is displayed on both PFDs. To align the IRs, the aircraft present position must be entered into the FMGS. This leads us into the procedure for entering information into the FMGS through the MCDU. The outline keys are page select keys. Each key calls up a page with information specific to that regime of flight. For instance, the flight plan key calls up a page which is used either to build a flight plan or to check a company route. The performance page is used to enter V-speeds, climb, cruise, and descent speeds. To enter data into the FMGC, we use a specific page key sequence. By using this pattern, we avoid several pitfalls that could possibly cause delays. There is an acronym for this pattern created by using the first letter of each key involved in the setup. DIFRIPS, D-I-F-R-I-P-P-S. The relation of letter to key is explained on the next page. Data key. Initialization A key. Flight plan key. Radio navigation key. Initialization B key. Performance key, 4 separate pages to fill out. Progress key. Secondary flight plan key. The MCDU is organized in terms of phase of flight. For instance, when the aircraft is first powered up, the FMGC status page is automatically displayed. This page is the data page, the first page in the acronym. All information on this page must be verified before any other entries can be made. Items that need to be checked include the type of aircraft, the engines used, and the date of the navigation database. Notice the color coding. White indicates a title or a label. Blue indicates a modifiable value. Green indicates a value which cannot be modified. There are other colors which will be explained as we encounter them. This color coding is used throughout the MCDU. Next, the present position must be entered into the FMGS. This is accomplished on the Init A page of the MCDU. To select this page, the Init key must be selected. Press the Init key. The Init page is the first page on which you input data. Notice the amber boxes. Data entry is mandatory in these boxes. Notice the fields with white dashes. These dashes mean that the FMGC does not yet have enough information to fill in these fields. As we provide more information to the FMGC, these fields will become active. Note the blue data in the lower right corner. This is the default altitude for the tropopause. The blue color means it can be changed. If we do not change it, the FMGC will use this default for its performance computations. There are two methods of entering present position. One method is to enter the four-letter ICAO airport identifier into the scratch pad and line select it to one right. This requires building the entire flight plan. The other method is to type a company route into the scratch pad and line select it to one left. Using the first method, the four-letter identifiers for Orly, France and Cairo, Egypt have been entered into the scratch pad. Now line select these two airfields to the From To field by pressing the one right key. A page showing all possible stored flight plans for these airport pairings is automatically called up. Should a plan be shown, it must be carefully checked against the ATC flight plan for accuracy. In this case, there is no stored plan. Now return to the initialization page by pressing the 6th left key. Note that the latitude and longitude position of Orly Airfield have automatically been entered into the MCDU. Although this data has been obtained from the aircraft database, you must confirm that this position is correct by reference to airfield charts. UAL does not align to a gate, but to the airport center. These coordinates are found on the 10-9 or the 20-9 Jefferson pages. Should the data be incorrect, the pilot may change the latitude and longitude. Notice the up and down arrows beside the latitude title. These arrows are telling you that the latitude information can be adjusted by using the MCDU slew keys. In this instance, the latitude is incorrect by 1 point of a minute. Press the MCDU slew up key to change the latitude information. The latitude has been increased by 0.1 of a minute. The longitude may be changed in the same manner, but first the slew arrows must be transferred to the right side of the MCDU. To change the slew arrows, line select for right. The slew arrows have now moved across to the longitude title. Longitude information can be adjusted in a similar manner. Let's assume the longitude is also incorrect, reading 1 point of a minute too high. Press the MCDU slew down key to change the longitude information. The longitude has been decreased by 0.1 of a minute. Using this method, it is possible to fine-tune the position. The other method, less used anymore because of new ATC routing methods, is to use a company route. We have inserted the company route ORLCAIRO1 into the scratch pad for you. It corresponds in this database to a flight from Paris-Orly to Cairo. Line select this route to the company route field by selecting the one left key. This page presents all the flights from Orly to Cairo which have been stored in the database. In this case, there is a company stored route which agrees in all respects with the ATC flight plan. Since there is agreement, we would choose the insert prompt. Press the line select key 6 right. The company flight plan has been entered. Note that this method has also entered the latitude and longitude of the departure airport. Again, this data must be confirmed by reference to the airport charts, and the data can be adjusted as before. The advantage of this procedure is that the flight plan is automatically entered into the MCDU, rather than having to be manually built leg by leg. Either of these methods brings up a new prompt, Align IRS. Once you have confirmed that the position is correct or have made the necessary corrections, you can send it to the ADIRS by line selecting the Align IRS prompt. Press the line select key 3 right. The coordinates have been sent to all 3 IRs, and the Align IRS prompt disappears. Next, the IRs are checked for accuracy. On the ADIRS panel, the data knob is switched to PPOS, present position, and the system selector to 1. The coordinates shown in the digital display are checked for accuracy. When the number 1 IR is verified, the system selector is moved to the number 2 position for verification, and then to the number 3 position. The IRS in Align message on the engine warning display counts down the time remaining until full alignment is completed. We have speeded up this countdown for you. If the position has not been inserted, the countdown will stop at 1 minute. In the MCDU scratch pad, a message, Enter Present Position, appears, and the Align lights on the ADIRS panel will begin to flash. Once IRS alignment is complete, all PFD and ND information is available. The IRS in Align message disappears from the engine warning display memo, and the ADIRS control panel Align lights extinguish. For the remainder of a normal flight, no further pilot input is required to the ADIRS system. Once present position has been entered, the remainder in the Initialization A page is filled out. Flight number, cost index, cruise altitude, tropopause, and climb winds. When Initialization A page is complete, we proceed to the F in DIFRIPS, the Flight Plan page. Call the Flight Plan page. This is the Flight Plan page. It can be thought of as an electronic scroll or roll pad containing all the waypoints of the flight. There are 2 different ways of placing information on this page. If there is a company route, one left on the Initialization A page, selecting that route will install the flight plan for you. An example is shown in the next few slides. However, because of new FAA routing practices, there are very few canned flight plans left. The result is that the flight plan has to be manually entered onto the flight plan page. That process is the subject of the auto flight class in the training schedule. To use a company route, you simply type the route into the scratch pad at the bottom of the screen using the keyboard. In this example, a flight from Paris-Orly, ORY, to Cairo, CAI, ORY CAI-1 is typed in. The route is then inserted by pressing line select key 1 left. The company canned route has been installed. It can now be reviewed for accuracy. Notice the up and down scroll symbols. These slew keys are used to scroll the flight plan waypoints up or down. The up arrow is used to bring later elements of the flight plan into view on the screen. The down arrow scrolls elements which have rolled off the top of the screen back into view. There are white dashes on the page because there is insufficient information to calculate these values until further inputs are made. Once entered, the flight plan page will display the ETA, speed, and altitude for each waypoint of the flight plan. Notice the arrow symbol in the upper right corner of the display. It indicates that there is more than one page associated with this data. The next page is accessed using the key labeled Next Page key. Call the next page. The next page displays different aspects of the flight plan. The next page key is like a toggle used to navigate between two pages when they are available. In this case, the pages are called Flight Plan A and Flight Plan B. Time is replaced by estimated fuel on board, and ETA is replaced by wind. This is one way that the cruise winds from the dispatch papers can be entered. The destination airport is always displayed in white at the bottom of the flight plan page, regardless of the number of waypoints. Information regarding the destination can be called up at any time. Let's look at the color code used for the waypoints. The first one is always the from waypoint, and it is always in green. The second line depicts the to waypoint. It is always shown in white in order to differentiate it from the other waypoints. The rest of the waypoints are green except for the destination airport, which is always shown in white. It is important to note that the A320 always navigates from a point to another point. Let's compare the flight plan on the MCDU with what is displayed on the navigation display. LFPO 08 is the takeoff runway. Notice that it is displayed in green on the MCDU, but in white on the ND. The to waypoint, shown here as D086C, is displayed in white on both the navigation display and the MCDU flight plan page. Bearing and distance to go are also displayed in both places. The waypoint following the to waypoint is called the next waypoint. Notice that you can read a bearing to the to waypoint on the navigation display, and a track from the to the next waypoint on the MCDU. We will change the navigation display to plan mode to give us a better look at the flight plan. Switch from ARC to the plan mode. The plan mode is north-oriented, and it is always centered on the second line of the flight plan page display. Shifting to the plan mode enables you to scroll along the flight plan and see all the waypoints along the route. Using this mode is a convenient way to check the MCDU against the company-filed ATC routing. To scroll down the flight plan, you must scroll the present information up and off the view screen by using the Up key. Press the Up key. Even though the flight plan shifted, the waypoint centered on the navigation display is still the one displayed on the second line of the MCDU. We can now see the track or course to the third waypoint on the MCDU. In this way, we can check the course between each set of waypoints in the flight plan. Notice that the runway LFPO 08 has shifted off to the side of the screen. Its position has been replaced by the to waypoint. Also, the from indication has been removed from the MCDU since the from waypoint has now been scrolled up off the screen. Notice the triangle symbol displayed just after the waypoint D804. This indicates an overfly of the waypoint. An overfly means that the aircraft will not commence the turn to the new course until directly overhead the waypoint. Without the overfly condition, the FMGC will begin the turn to the new track before the waypoint, for smoothness and to stay within the lateral limits of the course. Overflies are programmed by first pressing the overfly key, then selecting the waypoint to overfly by using the appropriate line select key. Although rarely, if ever, used in the U.S., they are not uncommon in other countries. Notice the amber line. It is the Engine Out Standard Instrument Departure, or EOSID. If available, it is displayed in the plan mode for review purposes. Revisions are accomplished by using the line select keys, LSKs. Lateral revisions use the left LSKs, and vertical and other revisions use the right LSKs. We will modify the approach to the destination runway. Note that Cairo 23 right appears at both line select key 4 and line select key 6. It is UAL policy to access 6 left, even if the destination appears elsewhere. Line select key 6 left always contains the destination airport, regardless of the number of waypoints and the position of the flight plan. Select line select key 6. This is the lateral revision page from the destination airport. Notice the title Lateral Revision from Cairo 23 right. The coordinates of the waypoint are always given just below the title. There are several options available on this page. The functions available depend on the type of waypoint being revised. In this case, we have line selected a lateral revision from the destination airport. We will see other cases later on. Since we want to change the approach, we must use the function listed as Arrival. Pressing this key will take us to a page listing all the runways for the airport. Select the Arrival page. Here is the Arrival to Cairo page. There is an up slew arrow indicating that there are more approaches listed below the bottom of the page. Pressing the up arrow will show these additional approaches. In this example, the ILS approach to 23 right has been previously selected. Note that it is in green, meaning it is part of the active flight plan. We will select another runway. Select the ILS approach to 23 left. ILS 23 left is now displayed in yellow. Yellow means that the selection is temporary and must be confirmed before it is inserted. After confirmation, insert the new approach using line select key 6 right. Note, if you do not want to insert the temporary selection, you can erase by using line select key 6 left. Insert the ILS approach to 23 left. Once the change is inserted, the MCDU automatically returns to Flight Plan page A. The active runway is now 23 left. Notice the flight plan discontinuity between Altox and Charlie 123 Lima. The discontinuity exists because we have not selected a SID or approach transition. Rather, we are on radar vectors. Remember that in the plan mode, the waypoint displayed on the second line of the MCDU is centered on the MD, the navigation display. When there is no real waypoint, the next one is centered, in this case, on Charlie 123 Lima. Normally, the aircraft would be on radar vectors to final approach. However, for training purposes, we will assume that you have been cleared from Altox directly to Charlie 123 Lima. To do so, we must clear the discontinuity. Press the Clear key. Clear now appears in the scratch pad. We must now line select Clear to line select key 2 left. The discontinuity has disappeared on the MCDU, and there is a new leg joining Altox to Charlie 123 Lima on the navigation display. Now that we have changed the arrival runway, we need to go back to the beginning of the flight plan. The fastest way there is to press the flight plan key. We are now back at the top of the flight plan. Next, we will make a lateral revision to the departure runway. Press Line Select key 1 left. The options on the lateral revision page for the departure are different from those on the lateral revision page for the destination airport. Let's look at the two side by side. While a few of the functions are similar, most of the functions on each page relate solely to that specific phase of flight. We will now see how the departure runways are selected or modified. Select the departure page. The current runway appears in green at the top left and in the list of available runways, just as it did for the arrival page. The runways listed in blue are available for selection. The slew arrow indicates that there are more runways at the bottom of the page, which are not shown. The following information is given for each runway: the runway ident, the runway length, the runway course, and the associated guidance system, if any. Notice the next page symbol. There is another page of options associated with departures, which are accessed using the next page key. Select the next page key. On this page are the SIDs and transitions available for the airport. Notice the engine out SID. If there is an engine out SID for a selected runway, it is automatically displayed for review on the plan mode of the navigation display. If the aircraft is on a leg common to both the departure and the engine out SID, the engine out SID is automatically displayed should an engine failure occur. However, should the engine failure occur on a leg not common to both, the engine out SID will not be available. This page allows the selection of SIDs. Like its counterpart on the arrival page, where we can select stars, it is automatically called up when a new runway is selected. Both are always available manually by using the next page key. A third example of lateral revision involves an en route waypoint. This page has 3 new functions related to the en route phases of flight. Via, go to, used to build and modify the airway routing. Hold, used to insert a holding pattern. New destination. This function is used if at any time during flight the crew elects to proceed to a destination other than the one originally entered into the primary flight plan. A 4-letter ICAO identifier is entered into the scratch pad and is inserted into the flight plan. The new destination will then appear on line 6 of the flight plan. Let's look now at the vertical revision pages. They are accessed from the flight plan pages using the right line select keys. We have selected a vertical revision at D086C. Note that performance information is provided as well as line select functions affecting the vertical profile and performance. Notice information such as fuel predictions at the waypoint, entries for speed and altitude constraints at the waypoint, wind entries at the waypoint. This page also accesses the step prediction page, where step climbs and descents can be programmed. The flight plan is complete. The next item in DIFRIPS is the R. It refers to the radio navigation page. Call the radio navigation page. Check that the auto-tuned ILS agrees with the ILS for the departure runway, and manually tune any nav aid as required to comply with departure restrictions. On this page, you will also accomplish a VOT or VOR check. Continuing with DIFRIPS, we will now proceed to the I in the acronym. We have already filled in the information on this page. However, notice the next page arrow on the screen, which means that there is an initialization page B. Press the next page key. Initialization B is devoted to load entries and fuel planning. Notice that the zero fuel weight ZFW entry is mandatory. Several fields have blue default values, indicating that they can be modified. The fields with dashes indicate that the FMGC does not yet have enough information for calculation. Once the zero fuel weight has been entered, the next mandatory entry is block fuel, actual fuel on board. As soon as these entries are made, the FMGC starts to compute its predictions. All dashes are then replaced by the results. Non-modifiable results are shown in green. Items in blue can be changed. Taxi fuel defaults to 400 pounds, but it may be changed. Route reserve is calculated by adding FAA-required fuel to alternate fuel, if any. The final time entry is not used at United, so a 0 is entered into the block. The last line, extra time, is the hold and contingency fuel and time available. Initialization page B is accessible only before engine start. After that, it is automatically replaced by the fuel prediction page. Weight and balance changes occurring after taxi-out are entered on the fuel prediction page. Initialization B is used for pre-flight fuel planning and load inputs, while the fuel prediction page is used for fuel planning and modifications during the flight, that is, after engine start. Once the Initialization B page is complete, the dashes on the flight plan page are replaced by the FMGC predictions. The next item in DIFRIPS is the P, which refers to all the performance pages. Now call the performance page. Pressing the performance key displays the performance page for the current phase of flight. Note the amber boxes requiring the entry of V-speeds. The pilot manually enters the V-speeds. There is other information requiring verification or entry. Transition altitude, 18,000 in the U.S. and Canada, but differing in many Central and South American countries. Thrust reduction, acceleration altitude. The MCDU uses the ICAO default of 1,500 feet AGL. However, UAL uses 800 feet AGL in the interest of standardization. Engine out acceleration. The UAL standard is 500 feet AGL. Flexible takeoff temperature. The assumed temperature in centigrade for reduced thrust takeoff. Flaps trimmable horizontal stabilizer. The desired flap setting for takeoff. THS trimmable horizontal stabilizer is not used since UAL's performance is based on percent Mach rather than ANUs and ANDs. Takeoff shift used for intersection takeoffs. This is the distance down the runway where takeoff will begin, not the distance remaining. The other performance pages are displayed automatically as the phase of flight changes, or they can be accessed from this page through line select key 6 right. They are the climb page, the cruise page, the descent page, the approach page, and the go-around page. Only one entry is made on the climb page. The default is for the aircraft to climb at the econ speed of 250 knots. However, UAL policy is to climb at green dot speed until 3,000 feet AGL. Green dot speed is typed into the scratch pad and line selected into the blue speed brackets. The default for this page is an FMGS calculated econ cruise speed. However, UAL policy is to cruise at Mach 0.80 above flight level 310, or whatever is shown on the flight plan, and at 290 knots at flight level 310 and below. Again, this number is typed into the scratch pad and is line selected into the blue Speed Mach box. Again, the default speeds for descent are FMGS computed. However, UAL policy is to descend at Mach 0.80, or cruise Mach, and 280 knots. This is typed into the scratch pad and line selected to line 3 left. Since we do not have valid information for the approach page yet, we proceed to the progress page. Here we confirm that our selected cruise altitude does not exceed the recommended maximum. The final step in setting up the MCDU is to copy the primary flight plan to the secondary area, thus allowing the crew to have a backup flight plan in case something happens to the primary. This is accomplished by pressing the secondary flight plan key, then following the prompts to copy the active to the secondary. If desired, the secondary flight plan may be modified by changing the departure runway or by changing any of the en route legs.